Okay, good morning all. So in the last class, there was some mistake while discussing the protected access modifier. So like I said, public means any class, whether inside the namespace or outside the namespace, can access all the members or that particular member which is public. Private means only that particular class can access its own members. That particular class members can access the other members in the class. Protected means that class and its children classes can access those members. No other class can access those members. Okay, so this is an example where we have a presentation object, like in the PPT we have presentation object, right? And it has child classes like text, image. These are different kinds of presentation objects, so these are derived or inherited from the presentation object. Okay, now in presentation object there is a protected class, protected member called width. Okay, so this will be visible only to itself and its child classes. So text as well as image, they can access this width. Okay, now suppose if I try to access this width from the main class, you will not be able to access, because this program class, main program is in the program class. From here, if you try to access the width attribute directly, you see it is not visible. Actually it is a member of presentation object or text, or let me uncomment this line, say let me call it object 1. Now if I say object 1 dot width is not visible, height is visible, because height is not a protected member. You see, height is public, whereas width is protected. Okay, so it is not visible in other classes. So here if you see presentation object, object 1 dot, there is no width here in the list, height is visible. Okay, similarly if you created a text object, in text object also height is visible, although height is not defined in text object itself, it is defined in presentation object. Okay, height is defined in presentation object. You see text object, there is no separate member called height. Font style, font size are there, but height itself is not there. But still height is visible in text object. Okay, but width is not visible because it is protected. All right, so if you want to access width, or if you want to so if you want to access width, you can access it within the text class or image class. And if you want to make other classes access this, you create a public function. Like I said earlier, a method. You want to keep some members private or protected, but you want other classes to access them, you give the switch. You tell them how to access. So you give a method to the other classes how to access your protected members. So here we created a public method, that is set width. Okay, so since this method is public, this method is visible to other classes as well. That is why you can see here, when I say t1 dot, you will see set width. Okay, so set width is visible to any member. It is through this that we can give or assign width to text class. Okay, so that is what the function is saying. This takes some input and it assigns that input to the width member, width parameter. But this width parameter is not of text class itself, it is of the parent class, that is presentation object. But we didn't say anything, we did not say, we did not define width here again, nor we said this belongs to the parent. No need, because protected means it is visible to the child classes. Okay, so through this public set width function, we have set the width to some value. Okay, so we can call it, I already listed it here. So t1 dot set width 5. So I just said width is 5. It can be 5 inches, 5 units, whatever it is. And then again, how do we access that width? We can't again directly access that. We have to create a function to access that width. That function is also created within the text class itself. So we created another method called getWidth. So what does this method do? It just returns the value of width. Okay. So here we call t1.getWidth and it prints, we ask to print the value of width. Okay. So whatever width you have set here, that should be printed here. Okay. So let's just run this. So see, you got 5. Okay. So that's all. You want to make some members visible only to yourself as well as your children, make it protected. But other classes, for them to deal with this member, you create a method which is public. Okay. So that it is through this public method that other classes like this, like class program is neither it's not a child class or presentation object, it's a completely different class. But for it to change the width of presentation object, either directly through object 1 or through some of its child classes, you give a public method. So through this public method, you set the parameter or you get the parameter. So that's what we are doing. Okay. So that's about protected members. Okay. So now let's move on to working with C# scripts in Unity. Okay. So let me close this. Let me open Unity. Okay. So before we create a project, so first we download a zip file. So how we will go about is, we will first start with some existing codes. We will try to understand them, right? Some existing projects. We will try to understand the codes of those projects, and then we will slowly move towards writing our own codes from scratch. Okay. So this is a file which I downloaded from Unity site itself. So it's a zip file. I stored it in my projects folder. Wherever your Unity projects are being stored, I just stored it there. And let me unzip it. Okay, you got a new folder with a file called .unity package. Okay. So before I use this file, now let me go back to Unity. So just observe right now. You don't have anything to do right now. Just observe. Then later you can implement these things. So I say new project, and here there are many options, out of which we select 3D core, and here we can rename the project. I will rename it as mod cube because this is just about a cube and modifying it. Okay. I create this project. Okay, this is just a sample project that I created. I still did not link it with the Unity package. Okay. Now, if you just observe here in the bottom file navigator, so here you see some scenes folder. This is some sample scene. So this is what you are seeing here in the scene view. Just some sample scene, just some light and camera. That's all. Okay. But what we will do, we will import some existing scene from the package. So how do you do that? Go to assets and import package, custom package, and this Unity package you need to import. How did we get this? We earlier had a zip file. That zip file, yeah. So this is the zip file. When I opened that zip file, extracted the zip file, I got this folder inside which we have this Unity package. Okay. So I'm importing it into Unity, and it is this package consists of some script, some material, some scene. So all of them are selected by default. Anyway, you have to select all of them and import. Okay. Now you see this folder here. You will see a new folder here under assets. You see, you got a new folder here now. Earlier there was only scenes folder. Now you got another folder, that is mod the cube, within which all these three components which we just saw, they are listed. Okay. So now let me click this scene. This will show you the scene inside this package. So it is just a cube, just a simple plain cube, nothing more, nothing extraordinary. Now let us just run this and see what it does. So I click the play button. So it is just changed the color of the cube to green, and it is rotating it along x-axis. That's all. So that is all that it is doing. Okay. So let me stop it. So that is what this package contains. So it contained a 3D object, and that 3D object is given some material. Okay. And this 3D object is behaving in a particular way because of a script. So that script is what we will look at now. Okay. So very small script, simple. Now in this script, you see on top you have normal using system.collections, system.collections.generic, and also you have a new namespace called Unity Engine. So in all the Unity projects that you are going to do, you will have this in your script using Unity Engine. Unity Engine itself is a huge library of related functions which are related to Unity. Okay, so this comes with all those functions. Now we will, so what we can do, yeah, so let's go line by line. So here what is it saying? Public class cube colon mono behavior. So from this syntax, can you guess what is happening? Yeah, so what is the parent class? Mono behavior, right? Cube is the child class. So you just created a new class cube, and you are letting it inherit from a parent class called mono behavior. So this is an existing class in Unity. Okay, it is from this mono behavior class that it is in this mono behavior class that you have these methods called start and update. In almost every Unity script that you write, you will have both these methods, start and update. Okay, start is run once, the first time when your program is starting. It will set some things, and then update is called constantly. It's like a loop. You can imagine it like a for loop or whatever loop. This update happens every frame. Okay, why? I don't know if you when you play some games or whatever, or when you are buying a gaming laptop or something, one of the main things which you check for is the frame rate. Hertz, is it 120 hertz, 60 hertz, those kind of things. So our simple thing is frames per second, right? This you already know. Movie, we see a movie as a movie because it has how many frames per second minimum? 24 frames per second. Frame is nothing but an image or a shot. So when you run 24 images within a second, it looks as if those images are moving, or as if you get a video. Okay, that's how our eye functions. So for you to see any motion, any change, the images should be changing, but they should be changing at a high speed so that it looks like a video to you. Okay, if it changes at any rate less than 24, it looks broken. Like, you know, they are individual images. You don't see it as a continuous video. Okay, so that is the difference. Now in a very high speed game, many changes are happening. Like maybe you are shooting someone, right? Within that time, if that person is moving, or within that time if your bullet is not going at that speed, or if you are playing a car game, within the expected time if the car is not rotating, you will see that it is jittery, like it is going like this, like this, like this, like this. The direction, it is broken. I mean, the flow is broken, the movement is broken. So for your input to be translated onto the screen, for it to be rendered as fast as your input onto the screen, it should be updated very fast. The frames, every time what is happening is, it is splashing colors onto the screen. Okay, so every splash is like a frame. So it is continuously splashing. Or forget about games, even now when the screen is like this, it is not like it just splashed on the screen and the screen is static. No, it is constantly splashing the colors onto the screen. Continuously it is doing that. Just because we don't see any change does not mean it is not changing at the back end. It is constantly updating itself at the back end. That is the reason why when you are typing something, you are seeing the output. Like I type whatever, something. What is happening? When I type S, a new screen is coming. When I type O, a new screen is coming. When I type M, a new screen is coming. So every time the screen is being updated. So when the screen is being updated, don't think, okay, since I typed only this letter, only this pixel is being replaced. No, the entire screen is being refreshed. All the pixels are replaced. So it is waiting for your input. So it doesn't know when you are going to give an input, right? So it keeps refreshing. Whenever you give input, it just flushes it. So it does not refresh only when you give input. It keeps refreshing. When you give input, that input also becomes part of this refresh thing. Okay, so that is what is happening. So for any change to be visible on the screen, not only a game, normal, simple, this cursor blinking, it means the screen is refreshing every second or even more, many times per second. Okay, so when you are typing text, when you are doing anything, the screen is refreshing. That is what is happening. Okay, so that is the frame rate. The higher the frame rate, the smoother it is. Okay, the faster the changes you are making, all those changes will be visible. Otherwise, some changes will vanish. Right? Suppose if it is moving, say from point A to point B, suppose if it is 10 units distance, if it is refreshing for every 1 unit, it will be smoother. But if it refreshes for every 5 units, it will be obvious, right? Like it vanishes here, appears at the 5th unit. Again, it vanishes here, appears at the 10th unit. Like then you will imagine what happened to the vehicle in between or the object in between, right? So it has to vanish and appear at every unit or even every 10th unit, every micro unit. Only then it will be smoother. Okay, so that is what frame rate does. So you have to, so you can decide how much it should move between 2 frames or within a second. That you can decide. Okay, but no matter how much small number you give, if the frame rate itself is not small enough, your game will look jittery depending on the kind of game it is. Okay, if it is really a continuous, like a continuous race kind of a thing, if it uses high-end graphics and micro details, and if you have a very large screen, then any lag will be clearly visible to you. Okay, if the frame rate is not high. So you need a high frame rate in the hardware itself, and then on such a hardware you can program some things. Okay, so we will look at those things. So that's what update is doing. Okay, so update is updating. It can update different things. It can update, say, the position of an object. So object is moving from point A to point B. So it is like a for loop. Okay, move 1 inch right, then 1 inch right, then 1 inch right, 1 inch right. So move it until it reaches point B, right? So rather than writing a for loop, if you put it in update, it does it for every frame. Okay, so it can be any kind of updation, any kind of change. It can be linear motion or rotation or revolution, whatever it is. Any change that is happening in your game will be written in update function. That's all. So core of the game happens in update function. Okay, all right. So now so here you see some terms. These will be some regular terms that you will be seeing, like transform.position, okay, and then vector3, and then transform.rotate, okay, and in later codes you will see some more terms like component, get component, game object. Anyway, we discussed once, but game object also you will see. Okay, so these are some predefined classes and their attributes that we are using in Unity. Okay, now Unity itself has a hierarchy. So to understand the hierarchy, you just need to look at Unity documentation. Okay, so you see these are some important classes, right? Game object, mono behavior, object, transform, vectors, quaternion, scriptable object, time, all these kind of things. So there is a hierarchy among these objects. There is one more thing which I didn't, one example which I didn't show you is that, but this is quite obvious. I don't really need to spend much time on this. Suppose, so let's take this previous inheritance thing, or not inheritance thing. What was it? Encapsulation, constructors, classes. Okay, so here we have a class called calculator, and then we have a class called person, right? These are different classes. Now in program class, what are we doing? We are creating objects of different types. Calculator object we are creating, person object we are creating, and so on. Now suppose in person class itself, for some reason, suppose I have a member which is of a different class. You see, right now string is also a class, but it's an inbuilt class. Byte is also a class. Byte is not a class, byte is a struct, but you can think of it also like a class. It's an inbuilt class or struct. But I can also have a member which is of a user defined class. Okay, these are inbuilt classes or structs, but I can have a member which is of a user defined class. Or let's make it much simpler. So what I will do, let's copy, let's paste, let's say a point or geometry classes. Okay, so let me remove this cube also for now. So what we will do, so let me remove all this. So let me call this a point. Okay, so in this, imagine it's a Euclidean point. So what are its members? Say it's a 3D point, simple, public float x and public float y, public float z. So the coordinates, x, y, z coordinates of a 3D point. Okay, now in calculator, so this one, first of all, let me rename this as point, and this calculator also, let me remove all this, and let me call this a line. Okay, let me rename this as line. No, calculator. Okay, now a line is made up of points, right? So to define a line, we need minimum how many points? 2 points. So I just need to give 2 points. Okay, so all I need to do is public point P1, public point P2. That's it, right? Okay, now, okay, this is missing. Okay, now let's go to the program and so all we need to do is, first we can create point P1 equal to new point, and we can declare the object here itself, say x equal to 1, y equal to 0, 1 0 point. Okay, similarly I can create another point, say 1 1. Okay, now these are individual points. Now suppose I want to construct a line out of it. I can say line L1 equal to new line, and here I can say P1 equal to, I'm not sure if this will work, let's just check. So now suppose I want to print the values of these coordinates through the line segment. Okay, before creating the line segment also I can print them. I can just say print p1.x, p1.y, similarly p2.x and p2.y. Okay, let me comment this for the time being. So okay, 1 0 1 1. Now I want to assign these as points to a line. So I create a line object, and I say, okay, line has point P1. This P1 is the local P1. Yeah, it has detected it actually. Line dot P1 is given the value of local point P1. Okay, so this is correct. Now we can print all these as if they are part of the line. So let me comment these, and all that I need to do is add L1 in each of them. Okay, now let's see if it prints them. It printed. Okay, now suppose I want to directly start with the line, okay, not the points and then the line. Then what do we need to do? So all we need to do is we just say line, and then we say L1.P1 equal to, now can anyone tell me what I should write? how, what is x? There is no x. I commented all those. Imagine you don't have this code. Now you are directly creating the line with the points. How to do that? Yes, how do I give that? What should I write here? Earlier what did we do? We first created the points locally and then assigned those points to the line members P1 and P2. Now I want to don't first create them and then assign. While assigning itself, I want to create them. What should I write? Yes, yes. New point. Whatever you wrote here, just write the same thing here. This new point, x equal to 1, y equal to 0, right here. So earlier you stored it in a variable p1 and then assigned that p1 to your l1.p1. Instead of that, for l1.p1 itself, you create this new point and assign also in the same line. That's all. It's quite straightforward. Similarly, l1.p2 will be this another new point. That's it. Now let's see if this will work. It worked. Okay? Got it? So you can't assign them in the class declaration itself. That is like initializing. You should not initialize there. You should only declare. We are initializing here separately. So one way is you first declare some local variables of that type and then assign those local variables to your members. But that's just increasing, that's just duplicating your work. Why again local variable? Because that's just a temporary variable. You're finally assigning it to your member, right? So don't even declare a local variable, it's only a temporary variable. When you're declaring member itself, directly assign or directly create the new point or new object and assign it to your member. Okay? That's it. So that is what you will be seeing in this code as well. So let me, yeah. So you see in this code, it's saying transform.position equal to new vector. So transform is a class, position is a member of that class, and every time you should declare what the position of an object is. You should instantiate that position. So one way is you create a temporary variable called p, which is the coordinate of the object, and then assign the temporary variable to your transform.position member. But instead of that, you directly create that object and assign it to this member itself. Okay, so transform.position equal to new vector 3. So vector 3 is nothing but a 3D vector, xyz coordinates. So vector is actually a point. Okay, so an object is being created at this point. So you are giving the position of the object. That's all. Okay, and transform.local scale, that is basically what it is saying is, okay, vector 3.1 times 1.3. 1.3f means it's a float. That's why it is 1.3f. Okay, but what is vector 3.1? Vector 3.1 means all the units in the vector are being made 1. All xyz are being made 1. That is, all are made equal, and then it is uniformly scaled 1.3 times. You can scale it 3 times, 4 times, 5 times, any number of times. Okay, so rather than saying all the components in your vector are 1, 1, 1, it is just saying vector 3.1. Okay, so basically it is being repositioned to 1, 1, 1 and then scale to 1.3 times. Okay, all the axes are uniformly scaled. Okay, and then material is a class. You create some variable called material, and this renderer is again a class. So some classes you don't worry right now. Understand some classes which you will need to change. Some other classes, let them be like that right now. Just use them as they are. As you work on more examples, you will understand how to change them, modify them, etc. So this material class, this line you ignore for the time being. But this material class itself has a member called color. Okay, and this color again you need to instantiate. You need to give value to it. There is a, how do you declare color? There is an object. There is a class called color which takes inputs directly as its arguments. Okay, and it is taking 4 inputs. Any idea why 4 inputs? The first 3 are, suppose if it has only 3 inputs, what will be those inputs? For color, RGB values. They will be RGB values. Okay, these first 3 are RGB values. The 4th one is transparency value. How transparent it is. Is it opaque or transparent? Okay, how solid it should be looking. That's all. So this is called alpha. Okay, so I don't know if you have heard, if you do image processing, they are also called alpha channel. So how transparent the image is, that is mentioned here. Okay, so first 3 are RGB, 4th one is transparency value. Okay, so yeah, so that is the color of your this thing. Since this is 1, second one is 1, green is 1. That is why your cube is looking more green than red or blue. Red and blue values are still less. Okay, it is the shade of green because green is 1. If you give 1, it means that color you will get. That color is completely present there. Okay, so the maximum value is 1. You can think of it as the percentage. 100% green. Okay, 50% red, 30% blue. All right, and in transform.rotate, so what are we doing in update? We were rotating the cube, right, along an axis. So here again there are 3 inputs. Okay, this entire thing is 1 input. Then second input is 0, third input is also 0. What does this mean? This is saying that transformation happens along x-axis only. Y-axis and z-axis it is not transforming, it is not rotating along those axes. So along x-axis, by how much speed it should rotate? That is what we are specifying here. How many degrees it should rotate? Okay, so here it is 10 degrees. Okay, but then we are also multiplying it with some variable called time.delta time. What does this mean? This delta time is actually the difference of time between 2 consecutive frames. If you have say 24 frames per second, then how many seconds elapse between each 2 consecutive frames? 1 by 24, right? Sometimes your frame rate is much higher. If it is 100 frames per second, then the time elapsed between 2 frames is 1 by 100. Okay, so what we are saying is we don't know the frame rate of the machine. Okay, some machines may have 24 frames per second, some machines may have 100 frames per second, or some machines may have 120 frames per second. So when we say 120 hertz, the frame rate of your PC, of your screen is 120 hertz, it means 120 frames per second. If it is 60 hertz, it is 60 frames per second. Okay, so we need not worry about the frame rate. Depending on the machine, it will understand, it will calculate the frame rate and the time elapsing between those frame rates in terms of seconds and multiply the angle with that time between 2 frames. So if you have a large number of frames, the time between 2 frames is very small, right? So your rotation should be much smaller between two frames. Okay, so because it can afford such small rotations. If the frame rate is too large, sorry, if the frame rate is too small, that is you have very few frames in a second, say just 10 frames in a second. Okay, now if I keep the rotation angle also small, it will not finish its rotation to the angle I desired. Okay, so how to say it? Suppose I want to rotate a cube one full round in 1 second, 360 degrees. Okay, now the computer doesn't understand 1 second, it understands per frame. For one frame, how much angle should I rotate it? Okay, now in some machines you have 10 frames in 1 second, in some machines you have 24 frames in 1 second, in some machines you have 60 frames, in some machines you have 120 frames. Okay, now in all the machines, if I give number 10, what it does, so not 10, if I give 360, what it does, between every two frames it rotates 360, and okay, 360 is not a good example. Suppose I want to rotate a cube by 30 degrees. Okay, now in the machine with only 10 frames per second, what should I say? Rotate 3 degrees at once, so that it rotates 3 degrees, 3 degrees, 3 degrees like this 10 times, so that by the end of 10 frames it will rotate 30 degrees. Okay, but in a machine with 120 frames per second, how many degrees should it rotate between every two frames? It is 30 by 120. Okay, it is like whatever 0.3, 0.24, something like that. So now it should not rotate by 3 degrees, it should rotate by 0.24 degrees, then 0.24, then 0.24, and so on. So that finally it rotates 30 degrees in 1 second. Okay, so how many degrees it should rotate between every two frames, I need not calculate. If I just multiply it with time dot delta time, it will understand, okay, in this machine I should rotate 3 degrees between every two frames. On this machine I should rotate 0.24 degrees between every two frames. So this will do that. So 10 into 1 by 10, when you have 10 frames per second, so let me say this is 30 degrees. So I want to rotate 30 degrees in 1 second. So this will finally convert it to 3 degrees, because 30 into 1 by 10, 10 frames per second, 30 into 1 by 10 is 3. But if it has 120 frames per second, then it does 30 into 1 by 120. So 30 by 120 is 0.24. That's what it does. Okay, so how much angle, by how much angle it should rotate between every two frames, that is calculated, that is specified here. Same thing for distance, for everything, how much distance it should move. If it is linear transformation, by how much distance it should move between every two frames. Whatever distance you want to move in a second, give that number and multiply it with time dot delta time. It will convert it automatically. Okay, so I will show you how it works. So let's run this. So earlier it was 10 degrees, I updated it to 30 degrees. It is rotating slightly faster. Now let me change the number to say 100 degrees. Okay, so it will automatically get updated. Every time you update the code, you come back to Unity, it will automatically get updated. Slightly more fast, so let me make it more fast. Let's say, suppose if I give 360, let's see what happens. Much faster. Okay, now suppose if I remove this delta time now, I just give 360. Okay, nothing is happening. Why? Between every two frames it is rotating 360. So it has already rotated, but it's not visible to our eye, because what is happening between two frames is not flashing on the screen. It rotates and then flashes. It rotates 360, flashes on the screen. It rotates 360, flashes on the screen. So it looks as if it is not rotating at all. Okay. So if you give any 90-degree multiple, it will look as if it is static. So I can give 90, I can give 180, because it is a colorless cube, right? It is uniformly colored on all the sides. If it is differently colored on different sides, then 90 and 180 will be visible. But since it is uniformly colored on all the sides, 90 also looks identical, 180 also looks identical, 360 also looks identical. Okay, so let's make it 90. Same thing. It is rotating 90 degrees only per frame, but since it is uniformly colored, you are not seeing the change. Same thing will happen for 180 also. Okay. Now let me make this say 91. Okay. But you see, it looks as if it is rotating much faster than 360 degrees. When I gave 360, it was rotating still in a comprehensible fashion. But here it is rotating much faster. Why? Because here it is rotating 90 degrees per frame, not per second. Okay. So let me time dot delta time. Now you see it looks more meaningful. Okay. So always give time dot delta time. That's all. Okay. Yeah. Okay. And suppose let me give some value here also. Say 50. Yeah, I will. Right now I intentionally didn't give that. Okay. It looks very chaotic. Now you see, looks more meaningful. Let me give a value here also, say 120 to time dot delta time. Okay. Okay. Yeah. Okay, so these are the classes and their members that are used here. So why I gave you this example is line dot point, that kind of a thing. Here you were able to do a chain of dot notations, L1 dot P1 dot X, right? In Unity you will see many such examples of chains of dot notation, something dot something dot something dot something. How is that chain possible? Normally it is not possible. Class dot member, it is over. Okay, so far we just saw primitive members, int or string or byte or something like that. So you just stopped at maybe something like person.name, person.age, p1.age, something like that. Age does not have any member again. Okay, that is because age is a primitive type. Age is not itself a class. Age is just an int. But imagine if the member itself is non-primitive. The class is anyway non-primitive. If its members are also non-primitive, if its members themselves are again classes, again these classes have members which are classes, again those classes have members which are classes, then you can have as long dot notation chain as you want. So in this example, point itself is a class, line is again a class. That's why you could do L1 dot P1 dot X. Now imagine if X is also a class, then you can do L1 dot P1 dot X dot something. Okay, so that is what is happening. So I explained so that you don't get confused. So is position a member? Is position primitive or non-primitive? Because later you will see some examples where transform dot position dot X and transform dot position dot Y, transform dot position dot Z. That is in case you want to update individual X, Y, Z values, you can do like this also. You can say like you see this vector is 3, 4, 1, right? So one way of doing is you give all the 3 values at once. But suppose I don't want to give all the 3 values at once. I want to give one value at a time. Then I'll say dot X equal to 3. Dot Y equal to 4. Dot Z equal to 1. This is another way of specifying the values. Okay. So then you will suddenly wonder, okay, is position a member or a class? Right? If it is a member, how can it have dot notation? You will get that doubt, right? It is because I didn't cover classes being members examples in the previous lectures. So today I showed you if class is a member of another class, then this class itself can have other members. So it is through the parents, child's class, again child's class, you can have this dot notation accessibility. So that's what I wanted to say. Okay. Code for line program. Yeah. Line class you want to see? Yeah. So here class line is a class, and this public point P1, this point is a class which I defined in another file. Yes, that's what we did in program. Yes, so you see the program, you see in classes you don't define objects. Neither in point class nor in line class you don't define a line object or a point object. All objects are created in the main function. The point class just became a member of line class. You didn't create any object per se. I mean, it sort of, yes, you created, but you didn't initialize it. So that's what I wanted to say. Yes, this is an object, P1 is an object, P2 is an object, but you didn't initialize it. Okay. Now, in program, what we are doing, there are 2 ways. I initialize individual points first, okay, and then assign them to the lines members. L1.P1 equal to P1, L1.P2 equal to P2. That is one way of doing it. Another way is don't have these intermediate local points P1 and P2. Directly L1.P1 you give the value, you initialize it. L1.P2 you initialize it. You can do that also. So that's what we were doing here also. In this material.color we are directly initializing new color. Another way is I can have a C1 variable and initialize this color, okay, and then assign C1 here. But C1 is just wasted, it's just a temporary variable. So you don't need to use any of those things. Okay, so color is a member of material class, but color itself is a class. So you are creating an object of type color using new color syntax. Okay, that's what. So you can create object at any level. You can create object at material level, or you can create object at color level, or you can create object at, if it has another class member, at that class level, anything like that. Okay, so to understand the relationships between these classes, it is better if you look at Unity documentation. So game object we already mentioned, like all the objects in your game are actually game objects. Like this cube is also a game object. Okay, earlier we played some micro games. The player, they're all game objects. Okay, so game object itself. Okay, scripting. So let's go to scripting. This is clear. So game object itself is a class in Unity Engine, okay, but this class inherits from object class. This object class is different from C Sharp's object class. I don't know if you remember, I said in C Sharp every class that you create inherits from a parent, super parent class called object class. So whatever methods are there in the object class, those will automatically be visible in the user defined classes. So when you write dot, you will see some new methods, new members. Where did they come from? They came from the object class, which is predefined in C Sharp, okay? But this object class is not that C Sharp's parent object class. This is Unity's highest class. Unity also have a name called object class. It is from this super class, object class, all other objects are inherited or they are members of, okay? So this game object is a child class of object class, okay? And this is the namespace in which it is implemented. So in case you want to use game object, you need to use this Unity Engine.core module, right? And this game object itself has some properties, okay? And constructors and public methods, static methods, all kinds of things. Now, suppose instead of game object, let's look at mono behavior. Like we just saw, cube inherited from mono behavior. Mono behavior is a class. So you want to see what is in that class and what is it a member of, what is it inheriting from, right? So click on mono behavior. So switch to scripting. Actually here itself, if I look at scripting classes, that will be easier, I suppose. Instead of classes, Unity Engine. Just a minute. Scripting, yeah, I am in scripting only. Scripting concepts. Anyway, there will be so for each class you can look at it in two modes. One is scripting mode, okay? Another is documentation mode, I think. So if you go to scripting mode, you will understand this better. I believe I remember accessing scripting mode directly from this menu. Even otherwise, if you come to any class, even in documentation mode, you will see the scripting mode also of each class. So namespaces, attributes, yeah, so mono behavior. So we can just search mono behavior. Yeah. Switch to scripting. So here you see, again, this is a class, okay, and inherits from behavior. Behavior is a parent class. Now, where is behavior coming from? Just you can click on that. Now, behavior is again a class. It is inheriting from component. Where is component coming from? It is coming from object. Okay, so object has a child class called component. Component has a child class called behavior. Behavior has a child class called mono behavior. And from mono behavior, we are inheriting our classes. Whatever classes we are creating, we inherit most of them, most of the times from mono behavior. Because the start and update functions are defined in mono behavior. Okay, but in transform, what is the relation between transform and position, transform and rotation? That is not parent-child relation. You can't use dot notation with inherited class. Like earlier we had presentation object and then text and image. You don't say presentation object dot text dot image. You don't say like that. Okay, they are inherited. When do you use dot notation? When a class is a member of another class. Okay, that is not a parent class. That's just a member. Okay, one way of thinking of it is like in set theory, an element belongs to a set. The belonging relation is different from subset relation. Okay, like we can belong to the set of all people. Okay, but say men and women, they don't belong to the set of people. They are subsets of people. men is a subset of people, women is a subset of people. We belong to either the class men or the class women, and we also directly belong to the class people. Only elements, individual elements belong to a set. Set itself does not belong to a set. Set is a subset of another set. Okay, so inheritance is like set subset relationship, whereas belonging to is like an element belonging to a set. Okay, so transform and position. So let's look at that. So transform class is there. Now this is inheriting from component. Okay, so you cannot use component dot transform, but transform will have a member called position. Properties are nothing but data fields. Okay, so you see you have position. Okay, now position, if you click, it is not it is a type of vector 3 element. Vector 3 is the class actually. Okay, it is a struct. So class and struct I am not differentiating right now, don't worry about that difference, but vector 3 is again like a class. This vector 3 is directly implemented. It is not inheriting, it is not subclass, any such thing. Okay, so these are some things. Just understand this difference between a member and inheritance. You can use dot notation only with members. In the line class, point is a member. Point is not inheriting. Point is not a subclass of line class. I showed. I did not write. So if you look at point, I did not write point colon line. I did not write like that. I am not inheriting point from line because point has no common properties with line. It's an entirely different class. It so happens that point becomes a member of line class. Only then you can use dot notation. Line dot point dot its coordinates. Okay. So whenever you are seeing this dot notation, transform dot position dot x or whatever, x is a member of position class or struct, whatever it is. Position itself is a member of transform class. Okay. If transform is a member of some other class, then you can use dot notation. So normally we also use dot notation like this. This dot transform dot position, which means this object's position is this. This object, transform it or rotate it by this much, translate it by this much. So transform class has members like position. What is the position of the object? Or methods like translate, rotate, right? Translate it by so much, rotate it by so much. Position is property, translate and rotate are functions. Act on that. Okay, so these are some things. But transform, although it is inherited from component, you don't write component dot transform because that is parent-child relationship, not member set relationship. Okay, so the more you work, these will get into your mind. So don't worry about that. But only thing is, for you to understand, when you have a sequence of chain notations, all the elements in this chain except the last element is either a class or a struct. Only then it can have another member inside it. Primitive members cannot have further dot notation. That's all. Okay, that's what you need to keep in mind. Okay, so let's stop here.